Hi, I'm Chiranjeev. I'm glad to share our research work on HyperSpaceX, radial and angular exploration of hyperspherical dimensions. This project is conducted in Image Analysis and Biometrics Lab at IIT Jodhpur. This is the overview of our HyperSpaceX framework, which is a novel discriminative feature representation arrangement learning framework that explores both radial and angular dimensions in multi-hyperspherical space in order to maximize interclass distances and minimize intraclass distances. HyperSpaceX shows the efficacy of multiple small and large scale image and face recognition data sets. So this is the motivation behind our research work, which shows that problem with the existing frameworks where intermixing of class features happens and when the model is trained using cross entropy laws, which focus on separability of features, whereas this discriminable features angular discriminable features which is created using the when the model is trained using arcfist laws, still there exists intermixing of class features. So this is the framework comparison. As in earlier there used to be a metric based learning where the contrastive laws helps to maintain the perform the feature discriminability based on the Euclidean distances, whereas in angular learning the discriminability is made using the angular variations, and whereas in radial and angular learning framework it shows the maintaining discriminability based on the radial and angular dimensions. So these are the existing loss functions, whereas contrast law is a metric based learning approach and cross entropy is a separability based measure, and whereas arcfist is a discriminative loss functions. So in order to achieve the goal of the HyperSpaceX, so that the radial and angular dimensions can be explored in order to maintain the enhanced discriminative feature space. So we include the propose the Dirac loss, which consists of cosine theta, cosine phi, and the delta terms in order to achieve the goal of the HyperSpaceX. So these are the various components of Dirac loss components, whereas the cosine theta plus m helps to maintain the discriminability in the angular dimensions with the additive margin penalty of m, and whereas cosine phi is computed by computing the resultant vector between the omega y, that is a scaled proxy vector up to radial factor r, and the summation of the embedding space. So dot product is computed between the unit vector of resultant vector and the proxy vector in the reverse direction, whereas delta helps to maintain the tightness of the clusters at the particular radial hyperspheres and discriminate the features in the radial dimensions. So since our hyperspace consists of radial and angular dimensions, so we have to compute the predictive measure based on radial and angular dimensions by computing the resultant vector by which is computed using a triangular law. So the prediction of the favorable class is made based on the minimum resultant vector. This is the latent space visualization. As we have discussed earlier about cost entropy loss and arcfist loss based feature space, and this is the proposed Dirac loss. As we can see, the clusters are highly tightened and at their particular radius, so it shows the efficiency in the radial and angular dimensions in order to achieve enhanced discriminative feature space. So the HyperSpaceX shows an improvement over image classification and face recognition datasets. In order to show the efficiency of our HyperSpaceX framework, we compared with on various computed results on various backbones and compared with existing and popular loss functions. So and also we showed the comparisons over various small scale, large scale, and very large scale image classification datasets and on 6 testing face recognition datasets in an open setting. These are the performance on image classification task. So, as first spiral plot is for the 2 embedding space. When the embedding space is 2, as you can see even in embedding space 2, it shows the higher discriminable performance. So for the second spiral graph shows about the 512 embedding space, and third for the 2048 embedding space. So we can observe that on various large scale, very large scale, and small scale and large scale data sets, our HyperSpaceX shows highest performance, SOTA performance, as compared to other existing approaches and loss functions. So this is the visualization of feature arrangement learning that happened in latent space of C400 datasets, which consists of 20 classes and 5 subclasses distributed in radial dimensions, and distinct classes are separated based on radial and angular dimensions. So this is these plots are shown for the face recognition tasks, whereas first plot is for verification performance when the model is trained using CASHIA web space dataset on ResNet 50 dataset. As we can observe that on these plots, we can observe the we have achieved SOTA or near to SOTA performance when the model is trained using CASHIA or whether using MS1v2 datasets. Further, the last graph shows the identification performance improvement over arcface by over arcface loss when the model is trained using arcface and the model is trained using distack loss. So distack loss based approach shows highest performance as compared to the when the model is trained using arcface loss. Thank you. For more details, please reach out to us at these email IDs, or for more details, please contact us at the poster number 26, poster session 6. Thank you.